In this lesson, we're going to learn about graphing rational functions. Example 1, how do I graph rational functions? So we have the function y is equal to a divided by x minus h plus k. So the first step that we're going to do is we need to determine where the asymptotes of the graph are. Yesterday, the horizontal asymptote and the vertical asymptote were both equal to 0. Today, we're going to look at some shifts that are going to happen with the asymptotes. And remember, those asymptotes are these boundaries in which these hyperbolas are going to be then pushing up or moving closer and closer to. So the first thing we want to look at is this x minus h. And so where you have this x minus h, this right here, it is left and right, except for it's the opposite. So it's the opposite of the left or right. And we'll talk about it, and I'll show examples of that in a minute. And then we have the number without the variable, which is our up and down shifts. All right, for number 1, graph the function and compare the graph to the graph of y is equal to 1 divided by x. And the 1 divided by x, remember, is our parent function. And so first of all, we're going to then make a table, -4, -2, -1, 0, 1, 2, and then 4. And now to save on some time, I'm going to be plugging these in. For example, I would take this x and I would put the -4 right down here, and I'd say 4 divided by -4 is equal to -1 plus 3, which is equal to 2. And I'm just going to give you these values because we're really just interested in what's happening then on the graph. Now, when we get to this 0, and we plug it in, remember that you can't have 0 on the bottom of a fraction, so that is where our undefined is. And then we'll have 7 and 5 and 4. So let's go ahead then, and we need to determine what our vertical and our horizontal asymptotes are. Well, our vertical asymptote here is going to be this right here, which is the x is equal to 0. Our horizontal asymptote is going to be, notice it's going to shift up 3. Y is going to be equal to 3. And so what we're going to do today then is we're going to then put these dotted lines in indicating the asymptotes. So we've got this 0, which is then going to be our vertical line. And then we've got that horizontal line that's going to be shifted up 3. So we'll come up here, and then this is where our boundaries are going to be. All right, so now let's go ahead and plot our points. So we're going -4, 2, -2, 1, and -1, -1. And so we've got this hyperbola that's going to come around, and there we go. And remember, it keeps getting closer and closer and closer to that asymptote, but it never does touch it. All right, and then on the other side, we have 1, 7, and then our 2, 5, and then our 4, 4. All right, so again, you've got this hyperbola that comes on down and keeps getting closer and closer and closer and closer, but never does touch it. All right, so our domain is all reals except for x cannot be equal to 0. And then our range, where you've got all reals again, except for our y, oops, I should have put a not, y cannot be equal to 3, because that's where that the asymptotes are, where those boundaries are on the hyperbola. Now, if we talk about the comparing it from the parent function, this top number it made it further away from the asymptotes. And then that 3, it shifted up. All right, so now let's pick some values again here. And we're going to go kind of quickly so we can save on some time. So -2, -3, -4, -5, -6, -7, and -8. All right, so we would have, plugging in the -2, we would have 5.6 repeating, and the -3 you'd have 5.5, -4 you'd have 5. Now let's take a look at what happens to this -5. Well, when you plug in that -5, -5 plus 5 is equal to 0. So that is creating the undefined. And then I'd have 7, and then 6.5, and then 6.3 repeating. All right, so now let's take a look then. Our vertical asymptote, our x, is equal to -5. Our horizontal asymptote is right here. It's y is equal to 6. Now let's go ahead and let's draw those asymptotes. So we're going to then draw the line. So our x is equal to -5. So we're going to go 1, 2, 3, 4, 5, and it's that vertical line that goes straight up and down. And then our horizontal is at it's shifting up 6. So we're going up 1, 2, 3, 4, 5, 6. All right. So we'd have then this asymptote right here. Remember, those asymptotes are the boundaries. All right, so now as we go to graph these then, notice that you'd have your -2. Now make sure that you're starting at the origin when you're doing this. Don't go over to the asymptote. So you're going -2 and then up 5.6. All right, so right about there. We have -3 and then 5.5, so kind of right in here. And then -4 and then 5. Okay, so kind of what's happening here is they're all kind of really close together. You've got this then that's going to keep going. It comes back around. And then again, it's going to keep getting closer and closer. All right, and then on the other side, we've got -6. So we're going to go -1, 2, 3, 4, 5, 6, and then we're going to go up to the 7. Okay, and then -7, 6.5, and then -8, 6.3, something right around there. And so again, coming on down. All right, so our domain then, again, is all reals, except for x cannot be equal to 5, and our range is all reals again, except for y cannot be equal to 6. All right, so now let's go ahead and let's talk about what's happened on the graph here then. So first of all, notice that with that negative, it flipped over the horizontal, so it flipped. It shifted up 6. And notice then that it went to the left 5. And remember how we said the opposite of whatever this is? And so this is a positive. You'd think about it going to the right, but it's the opposite of that. It's going to be shifting to the left instead of to the right. All right, so this lesson is going to get to be too long if we do number 3 and number 4. I do have these done and they've been posted into Schoology under the notes completed. So for right now, we can skip number 3 and skip number 4. All right, example number 2, how do I determine changes of the rational functions? All right, so one of the changes that we have learned is that if we have a negative, that is going to be a horizontal shift or horizontal flip. All right, and then when we have the a, as that a gets bigger, the absolute value of a, if it's greater than 1, it means it's further from the intersection of the asymptote. All right, and then remember our h, it's the left, right, opposite. So opposite of the left, right. And then our k is the up and down. All right, so now what I'd like for you to do is I'd like for you to pause the video and I'd like for you to then determine what the changes would have been made and to these 4, and then you can resume the video and check to see if you're correct. All right, so let's take a look here. So because the number is greater than 1, it's going to be further from the intersection of the asymptote. It is going to flip because we have a negative. It's going to be the opposite of the plus 3, meaning it's going to go left 3, and then it's going to go down 4. For number 2, it's not going to go further because the number is it's number 1. It's going to flip. It's going to go to the left 5 and up 6. For number 3, we have the number 2, so it's going to be further away. It's going to go to the right because it's the opposite of that negative 1. It's going right 1, and then it's going to go up 2. For number 4, it's going to be further from the intersection of the asymptote. It's going to go to the right 3, and then it's going to go down 1. All right, so example number 3, how do I write and solve real-world rational functions? So it says your football team is planning a bus trip to the Pro Football Hall of Fame, and the cost of renting a bus is $500. So bus is $500. And the cost will be divided equally among the people who are going. One admission costs $13. All right, so we've got this cost. And then your bus, you're going to be paying the portion of the bus that is then going to be divided by the number of people, and then you'll be paying the $13 for the admission. So how much will it cost then if 10 people go on the trip? So if 10 people go on the trip, you've got your cost is equal to then the 500 divided by the 10 people that are coming plus the cost of the ticket. So we would then take the 500 divided by 10 and you get 50, and then we're going to pay for the ticket. And so that would be then $63. So each person then would pay $63. Where if 40 people go on the trip, you would have your cost would be the bus would be then not divided by 10 people, but by 40 people. But then you've got your cost of the ticket. So 500 divided by 40, everyone would be paying $12.50 instead of $50 for the bus because it's split among more people. And then you'd have your $13 for your ticket. So if 40 people went, you would then be spending a total then of $25.50. So in this lesson, we took a look at how to graph rational functions.